Hello, this is Mrs. Huntley. This is video 3 in your volume packet. Please turn with me to page 13, and this will be a lesson on the volume of spheres. So first of all, let's talk about what a sphere is. A sphere is a three-dimensional circle shape. It's from the radius is measured from the very center of the shape to any edge. And the radius is going to be the same going in any direction. I don't know if any of you had a sphere like this when you were younger and you could pull it and it would open up. But then you could see like the center of the sphere and coming out to the edges. And I don't have one that's all opened up. Probably the sphere that you're most familiar with is our globe. And although our globe is not a perfect circle, we usually depict it as being a perfect circle when we look at our globes. So half of a sphere, you may know already, is a hemisphere. So if we cut a sphere in half, right in the center, we'll see that the radius is the same going from the base, which is a circle, or any of the sides, because the top of the hemisphere or the sides of the hemisphere, whatever you want to call it, are going to be the same distance away from that center point as it was when it was whole. So let's move on to our lesson. Please add the essential question at the top, which I didn't do yet. How do I find the volume of spheres? S. Oh my word. Okay, let's try again. S-P-H-E-R-E question. Okay. The volume of a sphere can be found by using a formula. And I'm going to give you the formula here, and then we're going to talk about how the formula was derived. And then I'm going to show you a couple of different things about how everything is related. So our formula would be 4/3. Come on. Where's my pen? There we go. 4/3 times pi times radius cubed. Okay? And again, half of a sphere is called a hemisphere. Okay? So if a cylinder and a sphere have the same radius and the same height, the height of the sphere would be 2 radii. You're like, what? Let's look at the pictures. We've got a sphere here, and we have a cylinder that has the same height. So if we took this sphere and put it inside the cylinder, like this picture is over here, the height of the cylinder would actually be 2 radius of the sphere. Do you see how this would go up here and down here? So here's 1 radius, here's 2 radius. Or of course 2r would be a diameter, but that wouldn't help us in deriving the formula for the volume of a sphere. Okay, so if a cylinder and a sphere have the same radius and the same height, the height of the sphere is going to be 2 radius. Then the sphere will have 2/3 the volume of the cylinder. You're like, wait, what is happening right now? Use this fact to help you see how the formula for a volume of spheres was derived in the table below. Hang with me here. I know it's probably not making perfect sense yet, but it will in a second. Okay, the formula for the volume of a cylinder. Hopefully you're remembering this one because everything we've done has been based off of this one so far. So it's pi radius squared times height. So that's the volume or the area of the base times the height. Okay, so we're going to replace the height because we said the height of our sphere is 2r, right? So we're going to replace the h. Instead of writing an h here, we're going to say it's 2r, 2 radius. Then we're going to multiply the formula by 2/3 because the volume of a sphere is 2/3 the volume of a cylinder. And I'll show you some visuals to help you understand this. So 2/3 times pi r squared times 2r. Then we're going to simplify everything. 2/3 times 2 is going to be 4/3. Pi stays pi. Then we have r to the second power times r. r to the second power times r is going to be r to the third power. Okay, let me show you a quick video that depicts the volume of spheres, cylinders, and cones real quick. Hang on a second. Okay, here we go. This will be a video that will show you how they're all related. They all have the same height. We've seen this part before, where we take the volume or the cone and we fill it into the volume of the cylinder. See, they both have a base of a circle. I'm just going to fast forward a little bit here. So he's going to mark it. And we know that this is going to be 3. Now he's going to do the same thing with the sphere. And we're going to expect it to fill up to the 2/3 mark. Come on. Here we go. So the largest is the cylinder. Second largest would be the sphere. And of course, the smallest then would be the cone as in terms of volume. Okay? Okay. Yep, that last third can be filled in with one more cone. Just a little visual to help you wrap your brain around everything that we're doing. Okay, so here we are back to our notes. So hopefully you understand now that the volume of the sphere is 2/3 as large as the volume of the cylinder. We've got our formula for the volume of the cylinder. We're going to multiply it by 2/3 and we're going to replace that height by 2 radii. And that's how we derive our formula. So now we're just going to use our formula. We're going to practice using it and solving for the volume of the sphere, okay? And we are going to use our pi button. We like our pi button. We're going to use our pi button. Okay, so our formula, 4/3 times pi times radius cubed. Plug in the values or substitute in the values. So 4/3 doesn't change. Pi doesn't change. Instead of r, I'm going to write 3 to the third power. Now, when I plug this into my calculator, I'm going to use the ABC button that is you guys know where the ABC button is, the fraction button. If you don't know, make a note of it, and you can actually use the division button. Just put 4 divided by 3 in parentheses times pi times your radius to the third power. So when I do this, I come up with 113, or approximately 113.097, which I would say round it to 1. And this, I don't have any units, so I'm going to say units cubed. Next one, same formula, 4/3 times pi times radius cubed. Now here I've got a diameter of 12. I find the radius by cutting that in half. So my radius is 6. Go ahead and substitute in the values. Four thirds times pi times 6 to the third power. Grab your calculator. Hit 904.778. So let's just round it to 0.8 units cubed. Last one, I want you to pause the video and do this last one on your own. Same formula, 4/3 pi r cubed. Pause the video now, substitute in the values, round to the nearest tenth. Okay. Again, I get that if you're confused by how the formula was derived, that might be a confusion, but being that you get a note card on this assessment, just make sure you've got this formula for the volume of spheres on that note card if you're not understanding how it was derived. Okay, in 4 to 6, they want us to find the volume of each sphere and leave our solutions in terms of pi. So this is where we multiply together all of the rational numbers and leave pi in our answer. So here, our diameter is 13. Half of 13 is 6.5. So our radius is 6.5. Our formula is the same as it was before. 4/3 times pi times radius cubed. Plugging in the values, 4/3 times pi times 6.5 cubed. In my calculator, I'm going to take 4/3 times 6.5 to the third power, and I get 366.17. I leave pi in my answer, and I don't have units, so I'm just going to say units cubed. Okay, try to do the next one for me. Same formula, 4/3 times pi times radius cubed. Substitute in the correct values. 4/3 times pi times 12 to the third power. Use your calculator. I get 2,304 units cubed. I would like you to pause the video and do the last one on your own, and then unpause the video to see how it goes. So pause the video right now, please. Okay. I'm going to end the lesson here because we're coming up on 15 minutes, and I think it would be best if I went over the rest of this together in class tomorrow. So have a great night, and remember, the volume of the cylinder, the volume of the cone, and the volume of the sphere are all related. Again, if you're not wrapping your brain around the relationships and how that will help you to just kind of intuitively know how to go about finding these volumes, just make sure that you have all of the formulas on your note card for the assessment next week. And hopefully the more you work with it, the more it's going to become second nature. Have a great night.